So today we're going to spend a second day discussing the graphs of polynomial functions. And so what you need to do is get these down and file away these to memory. A constant function has a degree 0. It's a horizontal line. That would basically be if you have like y equals something, like if you would have y equals 3, y equals 2, y equals -1. A linear function can look both like that. It could also go down this way. Okay? Linear function, remember, is just a line, like y equals x plus something. Quadratic function, we've looked at those. That's x squared. Remember, those can be both a frown and a smile. Goes, opens down, opens up. A cubic function, degree 3, looks like that. It could also look like this. Okay? A quartic function, what does that look like?
W.
A W. Another thing it could look like is an M.
Is it anything with like 4
Okay.
lines?
So well, sometimes it'll have 4, sometimes it won't. And a kintic function, degree 5, if you notice, kind of looks like a W or an M with an added line. Okay, so another way would be as if I would make a W and then an added line. So those are the functions. You kind of need to understand where they're coming from. We're going to take some things out of our book. First of all, the domain of any polynomial. So any polynomial that we choose is all real numbers. And the next thing is end behavior. The end behavior is the end behavior of a graph. Where does it end? How does it end? Okay, and so that is the behavior of the graph of f of x as x approaches positive infinity or negative infinity. So positive infinity we know is the right. Negative infinity is the left. Okay. It is determined by the degree and leading coefficient, and we're going to look at that. There's actually a table in your book that we're going to look at as well. Okay?
Are you even recording?
So now we're going to go ahead and look in your book on page 324. And so on page 324, you're going to notice this end behavior of a polynomial function. There's just a few characteristics that we need to understand. So the first one, the first column deals with even functions. So the degree is even. If the leading coefficient is positive, okay, what it's going to do is it's going to approach positive infinity from both the left and the right. So that means it's going to go up. Okay? If the degree is even again and it's negative, it's going to be negative infinity. The graph opens down. Okay, now when we say approaches negative infinity, you're probably wondering, what does that mean? That just means I do this. I do all the way down as far as I can go. So on both the left and the right side, it goes down as far as it can go. Now, if the degree is odd, okay, and the coefficient is positive, what we're going to do is we're going to have the same signs. So from the left, it's going to go to negative infinity, which is what it does right here. It goes down. And from the right, it's going to go to positive infinity. So as it goes up. So odd and positive, they're going to match. What do you think odd and negative are going to do? They're not going to match. They're going to be the opposite. So on the left and on the right, if you notice on the left, what's happening is I'm going up. Okay, so that's going to positive infinity. And on the right, I'm going down. So let's go ahead and look at the next thing. And this is what's really important. These figures aren't as important as the key concept right up there. Okay, the key concept. Odd degree functions will always have an odd number of real zeros. Okay, odd functions will always have an odd number of zeros. Even functions will always have an even number of zeros, or they will have no zeros. So basically what they're saying is even degrees. How do we know it's even degrees? Here I have no zeros. It's got to be an even degree function. Here, if you notice, I have 1, 2, 3, 4. Since I have 4 zeros, that's an even number. My highest power will be even. If I come down here and count my zeros, 1, 2, 3. That one has 3 zeros. It's got to be an odd function. Here I have 1 0. It's got to be an odd function. So basically all we're doing is counting zeros. So on today's homework, this is what you're going to have. It's going to be pretty straightforward. It's not difficult. So let's see what we do. For each graph, we're going to describe the end behavior. So we're going to talk about what does it do at the end. We're going to determine whether it represents an odd function or an even function, and we'll state the number of real zeros. So let's go ahead and start. Very first thing, I'm going to start with the left, and I'm going to start with the right. So on the left side of the graph, what am I doing as I move along the left side of the graph? Where am I going? Negative infinity. So my end behavior will be negative infinity. On the right side of the graph, what am I doing? Going to negative infinity. Is that too hard? No, pretty easy. Let's look at the next one. Determine whether it represents an odd degree or an even degree polynomial function. So what we're actually going to do first is we're going to determine how many zeros they have. So if I look at zeros, I have 1 0, because a 0 is where it crosses the axis, and I have 2 zeros. So I actually have 2 zeros, and so based on that information, I know that my function is an
positive
even function. And I know it's even because it has an even number of zeros. Let's look at the next one. Okay, very first I got to start left, and I got to start right, the end behavior. So on the left side of the graph, I'm going this way, which is positive infinity. On the right side of the graph, I'm going this way, which is negative infinity. Next step, let's count how many zeros I have. 1, 2, 3, 4, 5. So I have a total of 5 zeros. And so therefore, since 5 is an odd number, I have an odd function. That's it. That's all you're doing today. Now, eventually, what we're going to do is we're going to look at the graphs more in depth. Okay, but for right now, that's all I want you to identify. So I've got a few problems I want you to add to your homework. I need you to go to pages 326 and 327. I need you to add 35 through 40. Same instructions as what we did in class. You should actually be able to get those done now. Okay? So for tomorrow, make sure you get all of 5.3 done, as well as that 5.1 and 5.3 worksheet.